Welcome to SOS video, Unit 9, Lesson 2, about a system of linear equations that can be solved by graphing. So our system of linear equations means there's at least two, could be three, but we're usually going to work with just two, at least two equations with the same variables. A solution to a system means an answer that makes each equation true. So on this same set of axes, we are going to graph the pair of equations below. First, we need to make sure that these are set to y equals, which they are. Now I have two ways of graphing them. I could either go to y equals in my calculator and type in the equation, 5x minus 3. I'm going to go to my table of values. And I'm going to pick a few that would fit on my graph. Let's pick a few negatives. So -2, -13 would not fit on my graph, but -1, -8 would. 0, -3 would. 1, 2, and 2, 7. Okay, I can graph that. So pause the video, label your axes, graph those points, and connect them. Start the video again, see how you did. Okay, does yours look like mine? Remember, we start at the origin. For a -1, I go 1 to the left, a -8 for y, I go 8 down. I put a dot, and I continue doing the same thing with that. Some other people might say, instead of a table of values, I'd like to use the slope-intercept. So my slope is the coefficient of x, which is 5. I need to make it a fraction because I go in two different directions, 5 over 1. And my y-intercept is my constant, -3. And if you take a look, this is a point, -3. We would go up 5 and 1 to the right, up 5 and 1 to the right. So whether you did table of values or you did slope-intercept, you are still going to get the same exact line that's graphed. Okay, let's take a look at this one. So I want you to pause the video, either create a table of values or write your slope-intercept, and then start the video again, see how you did. Okay, if you use the table of values, you went to y equals on your calculator and you put in -2x plus 4. You looked at the table of values and you try to pick a few negatives, a few positives, but make sure the y is something that you could graph. If you decided to say m equals b equals, remember m is your coefficient of x, -2. I need to make it a fraction, so I put it over 1. So when the -2 tells me the y direction, it means I'm going down because it's negative. The number on the bottom tells me the x direction, and if it's positive, I go to the right. And my b value is my constant 4. So I could have gone to 4, down to 1 to the right, down to 1 to the right. Whichever way you chose, you're going to get the same correct dots. So I put a line through that. I extend it, I write arrows, and I write my equation somewhere close to that line. Okay, but I'm not done because I need to show where my solution is. My solution is where the two lines meet because that is going to be a point that is true for both of them. And my solution is 1, 2, the ordered pair 1, 2. If I put 1, 2 in here, it would make this true. And if I put 1, 2 in here, that would also make it true. So let's test it out. We have 1, 2. I'm going to write my first equation. Remember that this is x and this is y. So I'm going to put 2 in place of y, put 1 in place of x, and let's see if that works. 5 times 1 is 5, minus 3 is 2. So I know that's true. Let's try it with the other equation. Y equals -2x plus 4. In place of y, I'll put my y value of 2. In place of x, I'll put my x value of 1. So 2 equals, well, negative 2 times 1 is a negative 2, plus 4 is a positive 2, and that worked. So I know that my solution worked. I could see it on my graph, and I can see it here. But here's a really cool thing. The calculator is also going to show it to you. So remember we put negative 2x plus 4 in your calculator. Well, we're also going to write this one, 5x minus 3, and I'm going to press graph, and my calculator is going to graph both those lines. And it shows me that they cross at 1, 2. And if it's a little difficult to see that, I'm going to go to my table of values. And when x is 1, I notice the y value for both of these is the same. So 3 different ways to make sure your answer is right. We can graph it and see where they cross. We can take that number and make sure it fits in both of these. And we can check it on our calculator. Okay, the next one is a bit challenging. Read it to yourself and we'll discuss it. Okay, we want to graph this. So I know I'm going to graph. I'm going to label y and x here. But the problem is y is not by itself here. So I need to get it by itself. We call that isolating y. So instead of multiplying by 3, I am going to do the inverse operation and divide by 3, which means I have to do the same thing to every term there. 3 divided by 3 is 1, so we have 1y equals 2x minus 5. Now you can write your table of values, or I can say my slope is my coefficient of x, 2. I'm going to make it a fraction. My y-intercept is the constant. That's negative 5. The 2 on top tells me the direction of y. Since it's positive, we're going to go up. The 1 on the bottom tells me the direction of x. Since it's positive, I'm going to go 1 to the right. So let's try this. I start at negative 5 on the y-axis. That's where I begin. And the way I move is this pattern. So up 2, 1 to the right, put a dot. Up 2, 1 to the right, put a dot. Up 2, 1 to the right, put a dot. And you keep on going like that. I take my ruler and I'm going to connect the dots. I'll put an arrow at the ends and I'll write my equation. You could write the original one or your simplified version, your choice. Okay? And that is one of the lines. Let's take a look at this. Not ready to graph yet. I'm going to have to move the 2x over. So instead of a positive 2x, I am going to subtract 2x on both sides. That's a 0 pair. Y equals negative 2x plus 7. Okay. You know what? This was not... I'm going to graph this to show you something really interesting. Okay. So the slope is negative 2. We're going to put it over 1. And my y-intercept is 7. Okay. So let's see what we do. The negative 2 on top tells me the direction of y. Since it's negative, I'm going to go down. The 1 on the bottom tells me the direction of x. Since it's positive, I'm going to go to the right. This is where we begin. So I go to 7 on my y-axis, put a dot, and I'm going to go down 2 and 1 to the right, put a dot, down 2, 1 to the right, put a dot, and I keep on going that way. Okay, when I have 4 or 5 dots, I'm going to take my ruler and I will draw a line through it, extend the line all the way of the plane, and put arrows, and then remember to write your equation. You could write your original equation, or you could write the simplified one. All right, we're going to find the point of intersection of the 2 lines. Do you remember what that's called? You're right, it's the solution. And when we write the solution, we need to write the ordered pair. 1, 2, 3, 1. Okay. Remember, to check to see if it works, we're going to put it in both equations, and we go back to the original equation, just in case we made a mistake when we simplified it. Okay, we're looking at our solution is 3, 1. This is my x, this is my y. So we're going to replace the y value, 1, where I see the y, and we're going to replace the x with the x value, 3. And let's see if that's true. 3 times 1 is 3. This is 18 minus 15. Is it true that 3 is equal to 3? Yes. But remember, a system of equations, their solution has to work for both equations. So let's write the other original equation, 2x plus y equals 7. In place of x, we're going to put our x value of 3. In place of y, we put our y value of 1. And let's see if that makes this equation true. 6 plus 1 is 7. 7 equals 7. So you have graphed a system of linear equations. Even when they weren't having y by itself, you figured out how to do that. We found the solution, which is where they intersect, and we made sure that that solution worked for both equations. So tomorrow, we're going to get a chance to practice this.